Okay, so we're up to the last chapter, chapter 11. So it's build a small network, so sort of a scenario sort of thing. Plus, as I said, it adds a bit of security and troubleshooting as well. So we'll look at network design. So of course, before we build a network, you've got to design a network. And so we'll look at identifying devices that should be used in a small network, what protocols it would use, and basically how a smaller network, if designed well, will scale well to become a larger network if the business grows. Okay, so we're going to look at how we configure switches and routers with device hardening features. So basically security, and so we'll sort of get around, just basically making them harder to hack. And we'll look at network performance, and so we'll look at creating a baseline for networks using different tools, and we'll also look at network troubleshooting. So network design. So the majority of businesses are small and typically require small networks consisting of a single router with one or more switches and possibly one or more wireless access points. The business might also have IP phones. For the internet connection, the router will normally have a single WAN connection using DSL, cable or an Ethernet connection. So managing a small network is similar to managing a large network, so you still need to do maintenance and troubleshooting of your existing equipment, and of course you need to secure your devices and information on that network. So how do we choose devices for small networks? So regardless of the size, all networks require planning and design to ensure that all requirements, cost factors and deployment options are considered. So of course the price is always an issue, and so it's always a toss-up between features and capabilities and price. So of course the speed and types of ports and interfaces, so choosing the number and types of ports on a router or switch is an important decision. Expandability, so networking devices come in both fixed and modular physical configurations for expandability and flexibility. So with fixed configuration devices, if you need to change your network to do something different, you might actually have to replace that fixed device with something else. While with a modular device, you can often buy a card that you can add into it and then change the way that device works. So of course operating system features, and so basically what do we need in the way of security, quality of service, VoIP, layer 3 switching, NAT, DHCP, things like that. So what do these devices support? IP addressing space must be planned when implementing a small network. All hosts within an internetwork must have a unique address. Different types of devices will factor into the IP design, including end devices for users, servers and peripherals, hosts that are accessible from the internet, intermediary devices. Planning and documenting the IP addressing scheme helps administrators track device types. For example, if all servers are assigned a host address in the 50 to 100 range, it will be easier to identify server traffic by their IP addresses. So reliability is another important element of network design, and network failure can be costly. He's not in here. Reliability is another important element of the network design, and network failure can be costly. So the figure to the left represents a data center network. There are 4 types of redundancy in this figure. So there are redundant servers, there are redundant links, and there are redundant switches and redundant routers. And so a server, link, switch and router could fail and the network will continue to function. Okay, so traffic management. The types of traffic and how they should be handled should be considered and prioritised in network design. Routers and switches in a small network should be configured to support real-time traffic such as voice and video. For example, voice and video should be high priority, SMTP medium priority, instant messaging normal priority, and FTP low priority. So it should be classified according to priority in order to enhance productivity of employees and minimise network downtime. And of course, better services for those ones that need it. So common applications, there are 2 forms of software programs or processes that provide access to the network. So network applications, and so the software programs used to communicate over the network. Some end user applications are network aware and are able to communicate directly with lower layers in the protocol stack. Examples include email clients and web browsers. And then our application layer services. Other programs need the assistance of the application layer services to use network resources such as file transfer and network principling. So we spoke about SMB last chapter. That's actually an application layer service that supports non-network aware applications. So each application or network service uses protocols which define the standards and data formats to be used to format and direct data. So common protocols. So DNS is very common, and so service provides IP address or website or domain name, so a host can be connected to it without having to use numerical IP address. DHCP server, of course, automatically configures a host, very handy, and also saves on human error for static IP address allocation. Most network professionals work with network protocols which support the applications and services used by employees in a network. So the figure on the left lists some common network protocols that are used in most networks, including small networks. Each of these network protocols define processes on either end of the communication session, types of messages, syntax of the messages, meaning of information fields, how messages are sent and the expected response, and interaction with the next lower level. So we've spoken about DNS and DHCP. Of course, there's SSH, email, web, FTP, and the like. So voice and video applications. Businesses today are increasingly using IP telephony and streaming media to communicate with customers and business partners. A network administrator must ensure that the network can support these applications and services, including a supporting infrastructure with appropriate switches and cabling. VoIP devices can convert analog signals into digital IP packets. After the signals are converted into an IP packet, the router sends those packets between corresponding locations. So in IP telephony, the IP phone itself performs the voice to IP conversion. Voice-enabled routers are not required within a network with an integrated IP telephony solution. IP phones use a dedicated server for call control and signaling. So real-time applications, so the network must be able to support applications that require delay-sensitive delivery. So there's RTP, or real-time transport protocol, and there's real-time transport control protocol. So RTCP, are two protocols that support this requirement. Small network growth. So the network administrator must allow for growth for small businesses and their networks. Ideally, the network administrator has enough lead time to allow the network to grow in line with growth of the company. To scale a network, the following are required. So you need to have a good documentation of both physical and logical design. You need to have a device inventory, so you know what devices are where and doing what. You need, of course, to have a budget, so of course, including a purchasing budget, and of course, traffic analysis. So protocols, applications, and services along with their traffic requirements should be documented. So, as a network grows, it's very important to understand the type of traffic that is crossing the network as well as the traffic flow. Protocol Analyzer is the primary tool used for this. It can also help identify any unknown traffic and its source. To determine traffic flow patterns, capture traffic during peak utilization times, perform the capture on different network segments, since some traffic will be local to particular segments. The analysis of traffic patterns can be used to help make decisions on how to manage the traffic for efficiency. So employee network utilization. In addition to understanding changing traffic trends, a network administrator must also be aware of how network use is changing. A network administrator has the ability to obtain in-person IT snapshots of employee application utilization over time. This information can help the network administrator adjust network resources necessary. These snapshots typically include OS and OS version, non-network applications, network applications, CPU utilization, drive utilization, RAM utilization. So security. So computer networks are essential to everyday activities. Individuals and organisations depend on their computers and networks. An intrusion by an unauthorised person can result in costly network outages and loss of work. Attacks on a network can be devastating and can result in a loss of time and money. Intruders can gain access to a network through software vulnerabilities, hardware attacks, or something as simple as password guessing. These intruders are called hackers. So 4 types of threats might occur. Information theft occurs when someone breaks into a computer for the purpose of stealing confidential information. Data loss or manipulation. This is breaking into a computer to destroy or alter data records. An example of data loss is a virus that reformats a person's hard drive. An example of data manipulation is breaking into a system to change the price of an item. And then there's identity theft, is a form of information theft where personal information is stolen for the purpose of stealing someone's identity. And there's disruption of service. This is preventing legitimate users from accessing services to which they should be entitled. Okay, when it comes to security, there's also physical security you need to consider. And so basically it's just equally as important as when it comes to security. There are 4 classes of physical threats that must be dealt with. So hardware threats, physical damage to servers, routers, switches, cabling, plant and workstations. Environmental threats, so temperature extremes, too hot or too cold, or humidity. Electrical threats, so things like voltage spikes, insufficient supply voltage, brownouts, unconditioned power and power outage. Then there's maintenance threats, poor handling of key electrical components like electrostatic discharge, lack of critical spare parts, and poor labelling. Lack of critical spare parts, I'm assuming that is actually. So, so of course, physical security, you should have all your servers and devices in locked cabinets or rooms, and of course, controlled access to those. Now, what kind of vulnerabilities do we have? So a vulnerability is the degree of weakness which is inherent in every network and device and includes routers, switches, desktops, servers and security devices. Typically servers and desktop computers are the devices under attack. There are 3 primary vulnerabilities that can lead to various attacks. Here are some of the examples. So technological, so you can have weaknesses within protocols, operating systems and network equipment. You can have configuration problems where unsecured user accounts, system accounts with easily guessable passwords and misconfigured network equipment. Then there's also, if your security policy is bad or non-existent, you can have inadequate monitoring and auditing of network and its resources. So, malware or malicious software. So it's basically software or code that is designed to damage, disrupt, steal or inflict damage on data, hosts or networks. Viruses, worms and Trojans are most common examples. So viruses are a type of malware that is propagated by inserting a copy of itself into or becoming part of another program. It spreads from computer to computer. So a virus, much like the biological one, which you'll know about at the moment, attaches itself to, a biological one attaches itself to another organism, and that's actually how it survives. They can't survive all that long outside of other organisms. So computer viruses are much the same. They normally need to attach themselves to an executable file, and that's actually how they sort of survive and spread. While worms are sort of a more modern thing, viruses have been around for 30 years or more. Worms are similar to viruses, but they can actually move around themselves, and so they often take advantage of system vulnerabilities, and so they can actually exist on a computer, and then they can actually search out other computers with the same vulnerability and move across. So a Trojan horse, much the same as the ancient Greek story, is it tricks you into thinking that it's something you need or want, but it ends up being quite the opposite, something nasty. And so you're normally tricked into loading or executing this malware, and then it basically gets itself into your computer and then often phones home and things like that. So not nice. Okay, so the way most attacks start is by reconnaissance, and so networks can fall prey to various network attacks. There are 3 major categories: there's reconnaissance, access and denial of service attacks. So a reconnaissance attack is where a hacker could use either NSLOOKUP or WHOIS to determine the IP address assigned to a particular entity, and then from there They can then start using fping to ping a range of IP addresses to see who is responding. Once they know what addresses are responding, they could use Nmap, which is a open source program, which stands for Network Map, to see what ports are listening on those hosts. And if you've ever looked at Nmap, it will tell you what operating system is running on that host and what services are running, what versions of the services. It's quite scary what they can figure out. Okay, so access attacks exploit known vulnerabilities in authentication services, FTP services and web services to gain entry to web accounts, confidential databases, and access other resources. There are 4 classes, so there's password, trust, port, and man-in-the-middle attacks. So password attacks, hackers use several methods including brute force, where they just hammer away at username password combinations, Trojan horse programs, or packet sniffers. Then there's trust exploitation, where an attacker can access a target system by taking advantage of a trust relationship between the target system and one that is compromised. And then there's port redirection, where a hacker installs software on a compromised host and uses that host to access a target host on a different port. And then there's man in the middle, where the attacker inserts himself into the middle of a conversation. A common type is a phish email that a victim clicks a link in on their mail. Okay, denial of service attacks. Attacks prevent authorized people from using a service by using up system resources such as disk space, bandwidth, and buffers. The attack can be caused by resource overload or malformed data. Now, denial of service attacks are the most publicized and the most difficult to eliminate. Here are some examples of denial of service attacks. So, ping of death. An attacker sends a malformed or very large ping packet. And then there's a SYN flood. An attacker sends multiple SYN requests to a web server, and the web server waits to complete the 3-way handshake. And so basically, if more and more of these attacks happen, it can actually start using up all of RAM, and then the server can crash. Now, ping of death, you'd have to have a pretty old unpatched operating system for that to succeed these days, but it certainly did work in the past. And so SYN floods typically won't bring servers down anymore. They normally have settings where you can have a maximum number of sort of incomplete synchronizations, but it still does deny service, though, because if you've filled your quota, then valid users won't be able to attach to that server, and so it still denies service, but at least when the attack finishes, it will be there and it will be able to run. And of course, the picture is actually showing a distributed denial of service. That's when someone has control of a botnet, and they can use quite possibly hundreds, thousands, or millions of hosts to attack a victim, and so of course, well and truly overwhelm their service. So, and that's what that is. And so an attacker uses many intermediate hosts called zombies to launch an attack on the victim host. So the intermediate hosts used to launch the attack are usually infected with malware, giving control to the attacker. And there's a Smurf attack, which is an ICMP-based attack, where an attacker broadcasts a large number of ICMP packets using the victim's source IP address, and the zombie hosts reply to the target victim in an attempt to overwhelm the WAN link to the destination. Now, how do we mitigate attacks? So backup, upgrade, patch, and update and patch. So keeping up to date with the latest developments is a critical part of the network security and defending against network attacks. So as a new malware is released, enterprises need to keep current with the latest versions of antivirus software. The most effective way to mitigate worm or other attacks is to download security updates from the operating system vendor and install patches on all vulnerable systems. To use a central patch server to install critical patches automatically is a very useful solution to this issue. So basically, keeping up to date is know what's happening out there. So there are quite a few security sites that will actually update you as new attacks happen. And then, of course, keeping everything patched is certainly a good plan. So, of course, backup. People can attack. And so if you don't have a backup of your data, that's you who's taking the risk. And so basically the rest is sort of keeping up with latest developments, but backup is preventative maintenance, basically. Okay, so when it comes to what Cisco calls AAA, which is authentication, authorization, and accounting, basically it means you should have a good setup where you keep track of what's going on. So authentication, of course, is proving who you are, and then authorization is now I know who you are, I'll let you do only what you're allowed to do, and then accounting, even though it sounds like dollars, it's normally about keeping logs of who's done what. And so basically that's how you can sort of keep track of what's going on in your network, or at least part of the way. So firewalls are certainly a useful tool as well. So there's two major types of firewalls. One is your border firewall, that's on the boundary between your internal network and the rest of the world. And of course you can also have host-based firewalls as well. So where every host has a firewall and controls what traffic can go in and out. So network firewalls will reside between two or more networks, control the traffic between them to help prevent unauthorized access. Host-based firewalls or personal firewalls are installed on end systems. So firewalls use various techniques for determining what is permitted or denied. So you can do packet filtering. So packet, of course, is layer 3. You have authorized IP and MAC addresses and unauthorized, and so you can block that way. Application filtering, and so you do that based on port number, and so some applications are allowed to go through, some are not. URL filtering, so basically you might have a white list where these are the approved places you can go, or a black list saying these are where you cannot go. Stateful packet inspection is basically where the firewall keeps track of every conversation that is going on through it, and it knows what should and shouldn't be happening with those conversations, and can block things that shouldn't, and so on. So it basically keeps track of every conversation. So endpoint security, or host is an individual computer system or device that acts as a network client. Common endpoints include laptops, desktops, servers, smartphones, and tablets. The company must have a well-documented policy in place that employees must follow, since securing endpoint devices is one of the most challenging jobs for network administrator. The policy should include the use of antivirus software and host intrusion prevention software. Now, device security. When a new operating system is installed on a device, the security settings are set to the default values. This usually leads to security threats, and default settings, including passwords, should be changed. There are websites out there that tell you exactly what passwords are on what models of devices. System updates and security patches should be installed. For Cisco routers, the Cisco Auto Secure feature can be used to assist in securing the system. It's basically a script that asks you a lot of questions about what you do and don't need to do. Here are some of the simple steps that should be taken to most operating systems. Default usernames and passwords should be changed immediately. Access to system resources should be restricted to only those who need those resources. Unnecessary services and applications should be turned off, disabled, or uninstalled if possible. So passwords. So passwords are critical in protecting network devices. So here are some of the guidelines you should follow. It should be at least 8 to 10 characters in length. The longer the better, but not too long, because then people start writing them down. Passwords should have some complexity, so a mix of upper and lowercase characters, numbers, symbols, spaces, okay, and so on. Do not use passwords based on repetition, common dictionary words, letter or number sequences, usernames, relative or pet names, biographical information, or any easily identifiable information. Deliberately misspell words in your passwords. Change your passwords regularly. Never write down your passwords and leave where anyone can find them. Use passphrases when possible. Now, again, you should change your passwords regularly, but if it's too often, again, that's when, if people keep changing them, they'll have to start writing it down. So some basic security practices. So in order to ensure that all configured passwords are minimum length, you should use security password minimum length command, and that will actually, then you supply a number, and that will be your minimum password length. You can also do service password encryption, over the left, to encrypt passwords in the configuration file, so that at least stops people from looking over your shoulder and seeing what the passwords are. Now, to protect from brute force attacks, you can actually block excessive login attempts to a device by setting a number of failures to occur over a specific time period. So in this case, there's a command for Cisco, which is login, block for 120, attempts 3 within 60. So in other words, if someone attempts three failed attempts within 60 seconds, they'll be blocked for 2 minutes or 120 seconds. So instead of brute forcing, they're only going to get 3 every 2 to 3 minutes. So that's not great for them. So setting an exact timeout on a router will automatically disconnect users if they've been idle. So if someone walks past and there's a console available, they would be able to get in, but if it times out and logs them out, they won't be able to do that. So SSH. Oh. Okay. We lost all the text. I'm not sure why. So basically SSH is secure shell. So it's the alternative to Telnet, which is basically unsecure shell. And so to get SSH working, you need to have a fully qualified domain name. So you need to do the host name of your device. You also need to give it a domain name. So in this case, it'll be r1.span.com. You need to create your key set, so public-private key set. And so that's with that crypto key generate command. And then from there, you need to have a local database. And so we've just created username Bob with a password of Cisco. And the secret actually does MD5 encryption. So much the same as your enable secret password does MD5. If you do, the normal command is username Bob password Cisco. And then that would be plain text in the config unless you've got that service password encryption. But if you do username Bob secret Cisco, it uses MD5, so that's certainly a good solution. Then of course you need to set it up to be the only protocol available on your virtual terminal lines, and so line VTY04, login local. So instead of just plain login local says use the local database, so again that Bob Cisco would come into play there. And then transport input SSH, and so that's the only valid protocol that it will respond to is SSH with that command. And so that turns SSH on, and so that is certainly a better plan than Telnet. Okay, network performance. So the use of ping command is a very effective method to test for network connectivity to a particular host, server or device. It's an important first step in troubleshooting network failure. So the ping command is part of ICMP, or Internet Control Message Protocol, and verifies layer 3 connectivity. And so a ping issued from iOS, such as a Cisco router, will yield several indicators. And so the exclamation mark means it worked, the dot means time expired, and U means you've got an unreachable message back from a router or device somewhere along the line. And so basically ping works by, when you type in ping, your host will send out an echo request to that destination, and then that request says, please send a reply, and so you get an echo reply back. And so in this case, 5 was sent, 5 received, all good. Now, that of course was the command ping and then the target. You can also do extended ping. So if you just type, you need to have privileged exec mode to do this. If you type in ping, it will then basically ask you a whole pile of questions. And so instead of the default 5, you can actually specify different information, so certainly useful. And so you can actually change your source address to be a different network number, just to see how it works, how it goes. And so when it comes to baselining, you can use pings for that as well. And so as you can see with this, when it was run on February 8th, we got a time of 1 millisecond, which is pretty damn good. Run March 17, and we got a time of 6 milliseconds. And so that's 6 times longer, which is not particularly good. Of course, you do normally get statistics about your average round trip and all that, which is also useful. So it averages all of these times together. Of course, these are all identical. And so you can actually form a baseline. Now, that does look like it's roughly the same time. Oh, no, it's not the same time of the day. One's 8:14 in the morning, and one's 2:41 in the afternoon. So, not necessarily the same thing. But anyway, So you might actually, of course, for your baseline, do pings different time of the day, maybe different days of the week, depending on how traffic in your network goes. So basically, that baseline gives you something to compare it with. And so I'm not necessarily a big fan of that at 8 a.m. That's probably before everyone's at work. But anyway, so you can do that with a ping, or you might actually do it with a trace route as well. So, of course, that's a useful thing to do. So a trace route is pretty good. It's also a very good troubleshooting tool. So basically, trace returns a list of hops as a packet is routed through a network. Each router is the hop, of course. And so if you're trace routing from this host to that host, it's going to go through these 4 routers. And so you'll get those 4 routers as well as the end device that you're trace routing to. And so it gives you time responses and things like that. If things aren't working well, you might get requests timed out, or stars basically. If you get 1 or 2 of them, it might mean that the router is actually not responding ICMP. That's an option you can actually set. Of course, if all you get is timeouts for the entire things, maybe since past your first router, maybe things are bad. But yeah, eventually it will actually, if things are good and these are just ignoring ICMP, it should actually get through to your destination and then come back, and so that can sort of help. So you can actually do an extended trace route as well, and so basically type trace route and enter, as much the same as ping. And so again, I think you need to be in privileged exec mode. Now, common show commands to actually look at how things are going. So show running config, not really a status, but of course you can see what's going, what's been set up on the router. Show interfaces will give you a page full of information for each of the interfaces. Show up shows the ARP table. Show IP route shows you the router's routing table, which is good information. Show protocols tells you what layer 3 protocols are running, so it'll be IPv4 and IPv6. Show version, of course, gives you information about the router itself and how much RAM it's got, what version of the operating system, and interfaces and all kinds of stuff like that. So it is good information. Now, you can do ipconfig on a host, or ipconfig/all, of course, gives you all of your information. And it gives you things like your MAC addresses, as well as DNS servers and DHCP servers, the whole lot. So a wealth of information there. And of course, I think we did talk in a previous chapter about ipconfig display DNS to see your DNS cache. Again, good for that. So ARP-A actually is ARP show me all, and so it actually shows you all of the MAC address resolutions that it's got in its cache, because they're dynamic, they are in the cache. And so you can actually delete entries if you need to. You can actually do ARP-D* to delete all of them. But you got to remember, you've got to be in administrative mode to be able to do that. So by default, command line doesn't open in administrative mode. So static probably means it's the host that you're looking at, and so it doesn't need to do anything dynamic to learn that. There is a protocol called CDP, Cisco Discovery Protocol. The name gives a bit of a hint that it's a Cisco only protocol. Other people aren't going to use CDP. And so basically, Cisco devices can learn about their neighbours, and so can give you some very good information about your neighbours. And so you can see on the display there, this show CDP neighbours, and so it's got 2 Cisco devices that are neighbours. You can actually do detail, and it will actually give you a screen full of information pretty much for each device. So it's good information if you're trying to fault find a network that you have no documentation for. It can help you map the network, and so you know what device is connected to what device. The problem is that it can be a security risk as well, so like many of these things. And so many people actually turn CDP off, because if someone manages to packet capture those packets, they will see details. So show IP interface brief gives you 1 interface per line, and it tells you the status. So physical interface is up and the layer 2 protocol is up. And so, yeah, good information. Now, debugging. So basically, if you're fault finding stuff that's going strange, debug can be a great tool. So show commands give you a summary of things that's happened since the router's booted up typically, while the debug command can actually show you things as they happen. And so they're showing in that screen there, debug IP ICMP, and so then someone's pinged, and then of course you've got ICMP packets that have moved, and so you actually get a line every time it sees an ICMP packet. And so there's debug IP many things. On Packet Tracer you may not see a lot of options, so debug IP space question mark, but on a real Cisco device, if you did that, there would be lots of options. So routing protocols and you name it, they all have debugging commands. And so basically it will tell you often what it's doing with that information and whether it's an error or not. So it's very good information for troubleshooting. Now, terminal monitor. Debug commands are great, but they go to the console. And so, by default at least, only go to the console. And so, to get that information to go out by SSH or Telnet, you actually need to do the command terminal monitor. And so that will actually then send that debugging information to your Telnet or SSH. And so you can turn on terminal monitor and that will do it. And then to turn it off, it's terminal no monitor. So troubleshooting. Now we're into troubleshooting. So we've already looked at some of the tools, certainly. So basically, for troubleshooting, the major thing you need to do is you need to know the methodology. So basically, technicians must be able to analyze the cause of a network problem before they can resolve it. The process is called troubleshooting. A common and efficient method is based on scientific method and can be broken down into 6 steps, shown in the figure to the left. How many devices on the network are experiencing the problem? If it's one device, start troubleshooting at that device. If it's all the devices, well then maybe it's one of your central devices that's got a problem. So basically, you need to identify the problem, as it said, and then from there you establish a theory of probable causes, and then basically the most probable one, you test that if that is the one, and then you try to fix that. If that works, great. Verify it, fix it, it's fixed, document it, away you go. If it doesn't work, that's when you start reiterating back to step 2 again. Maybe you need to revise your theory of the probable causes and so on. So you basically you cycle between 2 and 5 until you fix the problem, and then you document what found the problem, basically. So, in some cases, it may not be possible to resolve the problem immediately and may need to be escalated if it requires a manager's decision or someone with different skills to you. For example, troubleshooting, the technician discovers that a router module needs to be replaced. This problem should be escalated for the manager's approval since it might require a financial equipment. You might need to buy that new module. Basically, Cisco includes powerful tools to help troubleshoot and verify fixes, and so ping, trace route, and show IP interface brief are of course commands you can run, and so that can of course be used to either troubleshoot or verify your fixes. So some problems can happen with cables. Sometimes it can just be a duplex mismatch, and so one end might be half duplex, one end might be full duplex. They won't talk to one another. And so basically, you either need to turn auto negotiation on both ends, maybe it's off on one end, or you might actually need to hard set those to be full duplex or half duplex, what it is, so they agree and they can talk. And so here, basically, you will get a command for that, a console message for duplex mismatch, and so that should give you some hints. Show IP interface command will of course give you information about a particular interface. and so it can give you, gives you IP addressing among several other things. IP config, of course, on a host shows you your addressing information, and of course, one thing you might do once you've got that is maybe try pinging the default gateway. That's sort of a very basic test, but if you can't get to your gateway, you can't get to the rest of the world. And then from there, once the gateway is successful, maybe you try pinging google.com or something to see if you can get to the rest of the world. So a router might need to have a default route, and so do show IP route, and so gateway of last resort is set, and so of course, and here is actually the default route here, so it's a static star, and so basically it's going via the next hop of 10.1.0.2, which looks right to me. And so, of course, you can figure out what your DNS server is if you can't resolve names. And so from there, of course, all 8's, that's a Google DNS server. And so you can basically try pinging the DNS server to start with, and then from there, maybe doing NS lookup or something to see, to manually see if it's working. Okay, so that's the end of chapter 11. The last chapter for this term, and so basically this week we were scheduled to do the 3 chapters, and we've got some labs there as well. So so of course this is all in preparation for next week, the testing. All right, so I will see you at the WebEx session today, hopefully, or it may have been the past for you. Hopefully I did see you. And so have a, So of course the summary of this chapter is explain the features and functions of iOS software. We looked at so basically, what devices would you choose? We've looked at some of the settings you might use on iOS, and we've also looked at other design criteria. So there's the logo. And so, as I said, that's the last chapter for this term. Of course, we'll start routing and switching essentials later in April. Have a good one. Good luck with the testing. See ya.